Hello there and welcome to the Science for Sleep. Tonight we drift into one of the most extraordinary mysteries in the universe: water. It seems simple, a clear liquid that flows, freezes, and falls as rain, yet every drop holds an ancient story. The water in your glass may have once rippled across Martian plains, floated as mist above an ancient forest, or glimmered in the tail of a comet long before Earth was born. It is the most familiar substance on our planet, and yet still one of the strangest. It bends light, defies gravity, remembers the stars it came from, and carries the spark of life itself. Every drop of water is both ancient and eternal, a traveler through time that connects the dawn of the cosmos to the present moment in your hands. Every molecule whispers stories from the beginning of the universe, echoing the heartbeat of creation itself. Every drop on Earth has been here for billions of years, never truly disappearing, only transforming from vapor to liquid, from ice to mist, endlessly cycling through time. The same molecules that once drifted in the breath of dinosaurs now fall from modern clouds and flow through your veins. Each drop has journeyed through oceans, glaciers, roots, clouds, and the bodies of countless living things. Even the rain outside your window may once have been part of an ancient sea, and the water that makes up your cells could have frozen at the poles a million years ago, or boiled from volcanic vents beneath primeval oceans. On a planetary scale, almost no new water is created or destroyed. It is Earth's oldest traveler, eternally renewed and recycled, carrying within it the memory of all who came before. Every river, every tear, every wave that breaks on the shore holds the memory of deep time, whispering stories of the world as it once was and as it will be again. The hydrogen in water was born in the Big Bang. Before there were stars or planets, before there was even light as we know it, the universe was filled with a glowing soup of particles. In those first few minutes after the Big Bang, protons and neutrons began to form hydrogen, the simplest and most ancient of all elements. Every hydrogen atom that now dances inside a droplet of water has existed since those first cosmic instants, untouched by time itself. It has traveled through nebulae, through stars, through the cold darkness of interstellar space, waiting billions of years to find its partner. When it finally met oxygen, it formed the molecule that would cradle all living things. To drink water is to drink the first breath of the universe, to hold in your hands the very essence of creation. The oxygen in water came from dying stars. Oxygen did not exist when the universe began. It was born in the blazing hearts of stars that lived and died long before our sun was even a dream. Inside their cores, hydrogen and helium fused under unimaginable pressure to create heavier elements like oxygen. When those ancient stars reached the end of their lives, they exploded as supernovae, scattering their oxygen-rich dust across the cosmos. That dust drifted and cooled, eventually becoming part of the clouds that formed our solar system. When oxygen finally met hydrogen, water was born. Every raindrop, every ocean wave, every misty breath is the echo of those long-vanished stars. You could say that water is the universe remembering itself, the ashes of creation turned into something gentle, something that glimmers with the rhythm of life. Water exists in all known states of matter, solid, liquid, and gas, and can even exist in all three simultaneously. In the right conditions, water performs a quiet miracle known as the triple point, a perfect balance of temperature and pressure where ice, liquid, and vapor coexist in harmony. Deep within scientific laboratories, or sometimes in the delicate air of mountaintops, tiny ice crystals can melt and evaporate at the same time, shifting between states so quickly it seems they refuse to choose one. This extraordinary versatility is what makes water the sustainer of life. It moves freely between worlds, becoming cloud, rain, snow, or steam, shaping climates, carving canyons, and breathing life into the soil. The triple point is a reminder that water does not obey ordinary rules, it dances between forms with grace, forever fluid in identity. In that fleeting shimmer where ice, liquid, and vapor coexist, water reveals its deepest secret. It is not bound to one state but belongs to them all at once, existing as a bridge between worlds, between the solid and the unseen. Another remarkable property of water is that it expands when it freezes, something almost no other substance does. Most materials shrink as they cool, but water defies that rule. When it begins to freeze, its molecules arrange themselves into a crystalline lattice that takes up more space than the liquid around it. This simple quirk makes ice less dense, allowing it to float. The consequences of this are profound. If water behaved like other materials, lakes and oceans would freeze from the bottom up, trapping all life beneath layers of ice. Instead, the floating crust insulates the water below, protecting fish, plants, and entire ecosystems through the harshest winters. This quiet miracle of physics is the reason life on Earth survived through countless ice ages. Every frozen pond, every drifting iceberg is a living shield built from geometry and temperature, a reminder that even the smallest quirks of nature can determine the fate of entire worlds. The surface of a frozen lake may look calm and heavy, but it is actually lighter than the liquid beneath it. When water freezes, its molecules lock into a lattice that spreads them farther apart, reducing its density and letting the solid rest above the liquid. The result is one of nature's most elegant designs. Ice, under certain rare conditions, water can even break its own freezing rules. In a state known as supercooled water, it can remain liquid well below the freezing point. When cooled carefully and kept perfectly pure, water can resist solidifying because ice needs a starting point, a tiny impurity, a speck of dust, or a vibration, to begin its crystalline structure. Without that seed, the molecules keep moving, staying liquid in defiance of expectation. But the moment they are disturbed, the entire mass can freeze instantly, turning solid in the blink of an eye. Supercooled water exists naturally in high clouds, where droplets remain liquid until they collide with ice crystals or fall through turbulent air. These fragile droplets form the seeds of snowflakes, each one born from the sudden transformation of invisible vapor into glittering ice, a process as brief as lightning and as delicate as breath. Water's behavior, both familiar and strange, shapes everything we know. It sculpts mountains through erosion, carries nutrients through rivers, and regulates Earth's temperature by absorbing and releasing heat. Its surface tension allows insects to dance upon it, its transparency lets sunlight feed the plants below, and its fluidity connects every ecosystem into one vast, living network. In the human body, water is both substance and messenger, carrying minerals, regulating temperature, and enabling every heartbeat and breath. Even our thoughts rely on its presence, as the electrical impulses in our brains travel through water-rich tissue. The planet's blue shimmer seen from space is more than beauty, it is the visible pulse of a living world. From the cosmic birth of hydrogen and oxygen to the clouds drifting across your sky tonight, water has traveled an unimaginable path. It has been steam in a volcano, frost on a leaf, a tear on a face, and a drop in the deepest ocean. It connects galaxies to glaciers, stars to streams, the infinite to the intimate. Every time you hold a cup of water, you are touching the universe's oldest memory, the substance that has witnessed everything from the birth of the stars to the rise of life. It flows through your veins as it once flowed through rivers on a young earth, and it will continue long after we are gone, rising as mist, falling as rain, freezing, melting, and flowing again. In water's eternal cycle lies the poetry of existence, endless transformation, eternal return, and it is a fragile reminder that the world around us is not rigid but delicately balanced on thresholds, always one breath away from transformation. Among the many mysteries of water lies a strange and counterintuitive truth: sometimes, hot water can freeze faster than cold. This curious phenomenon, known as the Mpemba effect, was named after a Tanzanian student, Erasto Mpemba, who discovered it while making ice cream in the 1960s. He noticed that his warm mixture froze before his classmates' cooler one, and this observation would puzzle scientists for decades. The Mpemba effect defies simple explanation, and even now, no single answer fully satisfies our understanding. Part of the mystery lies in evaporation, which allows hot water to lose mass more quickly and cool at a faster rate. Another piece may come from the way heat changes hydrogen bonds within the liquid. When water is heated, these bonds stretch, break, and rearrange, loosening the molecular clusters. As the liquid cools again, the now separated molecules can more easily align into the crystalline structure of ice. Convection currents inside the container also play a role. redistributing temperature unevenly in ways that accelerate freezing under just the right circumstances. Yet, even when controlled, the effect remains inconsistent, appearing only under special and fleeting conditions. It is as if water is reminding us that even something so familiar can hold unending secrets. Every new experiment becomes a quiet lesson in humility, showing that nature still knows far more than we do. But the mysteries of water do not stop at Earth's surface. Deep beneath the shimmering clouds of distant worlds like Neptune and Uranus lies a form of water beyond anything imaginable on our planet, a phase called superionic ice. In these alien interiors, pressures reach millions of times those on Earth, and temperatures soar higher than the surface of the Sun. Under such crushing and blistering extremes, ordinary water transforms into something halfway between a solid and a liquid. The oxygen atoms lock themselves into a crystalline lattice, while the hydrogen atoms move freely within that structure, flowing like a sea of ions. This strange arrangement allows superionic ice to conduct electricity, glowing faintly with internal heat. It is a material both rigid and fluid, blazing and frozen, a paradox of matter that blurs the lines between solid and liquid. Scientists believe that this exotic phase of water helps explain the peculiar, off-centered magnetic fields of Neptune and Uranus, fields that seem to twist and tilt rather than align neatly with the planet's rotations. On Earth, researchers have recreated superionic ice for only the briefest of instants, using diamond anvils and powerful lasers to mimic the pressures of those distant worlds. For a heartbeat of time, they glimpsed the impossible, a glowing crystalline ocean that exists nowhere in nature except deep inside the hearts of frozen giants, where physics itself begins to dream. In those same distant depths, another wonder may unfold: diamond rain. Far below Neptune's calm, turquoise clouds, methane molecules are pressed so tightly that their carbon atoms fuse into tiny crystals of pure diamond. These glittering fragments drift downward through layers of ice and liquid, falling like gemstones through a darkened sea. Laboratory experiments here on Earth have shown that methane, under extreme compression and heat, can indeed form diamonds. If the same process happens on Neptune, its skies may shimmer with descending jewels, each sparkling briefly before vanishing into the heat below. Some scientists imagine entire layers of diamond within Neptune's mantle, or even floating diamond icebergs, suspended in the deep, churning interior. It is a breathtaking vision, storms of diamonds cascading endlessly through oceans of molten water, a universe where the strange beauty of physics becomes poetry. Within that endless, dark pressure, diamonds may fall forever, unseen by any eye, glittering in eternal silence beneath the crushing weight of alien seas. Yet even here on Earth, water performs miracles of symmetry and creativity. When it freezes in the open air, water molecules arrange themselves into forms of exquisite beauty, snowflakes. Each one begins as a microscopic seed, a speck of dust, a grain of salt, or a bit of pollen suspended in a cloud. Around that seed, water vapor condenses and freezes, its molecules guided by the natural angles of hydrogen bonds that always prefer a six-sided symmetry. The result is a crystal that grows outward in 6 directions, forming the characteristic hexagonal shape of snow. As the flake drifts through layers of air, temperature and humidity shape it in subtle, shifting ways. Some grow into long, needle-like shards, while others become wide, feathery, and ornate. The tiniest change in wind or temperature alters the sculpture in progress, and though every snowflake follows the same molecular rules, no two are ever identical. Each one is a fleeting masterpiece carved by chance and physics, an icy mandala that captures a moment of the atmosphere's history. Under a microscope, these frozen geometries reveal infinite complexity: branching arms, ridged plates, and perfectly symmetrical patterns, each one born from the same simple molecule yet utterly unique. Every snowfall is an art exhibition written in the language of temperature, humidity, and time. Inside the liquid form of water, an equally intricate performance unfolds, though it is invisible to the naked eye. The molecules in water are never still. They bond and unbond in a restless, ever-shifting ballet. Each water molecule is held to its neighbors by hydrogen bonds, tiny attractions that form, break, and reform within trillionths of a second. In that microscopic storm, every molecule is constantly switching partners, forming an endless network that both holds together and lets go. This ceaseless rearrangement gives water its strange flexibility, its ability to flow smoothly, absorb heat, and dissolve substances. If we could see the surface of a lake at the atomic level, it would not appear calm but alive with motion, a shimmering web of collisions, vibrations, and connections forming and dissolving in patterns too fast for thought. What appears still to us is, in truth, a living storm, a dance of attraction and release that never ends. Even when water appears frozen, its molecules are not truly still. Each one vibrates, spins, and twists in a rhythm set by temperature and the subtle rules of quantum mechanics. These vibrations stretch the bonds between hydrogen and oxygen like plucked strings, creating a silent, ceaseless hum of motion. The frequency of these oscillations is so high, trillions of times per second, that even in the coldest ice, the molecules retain a faint quiver of energy known as zero-point motion. It means that absolute stillness is impossible. Even at the edge of absolute zero, water remains quietly alive. This constant molecular motion allows it to absorb and redistribute heat, to dissolve minerals, and to sustain life's chemistry. Beneath the surface of every pond, river, or ocean lies this invisible orchestra, a symphony of atomic vibrations that has played since the first oceans shimmered beneath a young, glowing sky. And within each drop of water, there is more structure than the mind can truly grasp. A single raindrop may look small and simple, but inside it resides a universe of unimaginable scale. Roughly 10 sextillion molecules, a 1 followed by 22 zeros, inhabit that tiny sphere. That number is greater than all the stars in the observable universe. Each molecule is a perfect triad of atoms, 1 oxygen and 2 hydrogens, held together by nature's most fundamental forces. These molecules move, collide, and rebind in patterns of impossible complexity, creating the dynamic, fluid motion we call liquid water. When sunlight touches that drop, its molecules scatter and refract the light, breaking it into the colors of the spectrum, the source of every rainbow, every glint of reflected sky. Each droplet that falls from a cloud is a microcosm of the universe, alive with energy, geometry, and light. Water's mysteries reach even deeper, into the quantum realm, where it behaves in ways that defy all intuition. At the smallest scales, its hydrogen atoms can sometimes tunnel through barriers that should be impossible to cross. In the quantum world, particles are not confined to one place but exist in clouds of probability, able to appear on the other side of obstacles without passing through them in any classical sense. In water, this quantum tunneling subtly alters how hydrogen atoms shift within the molecule, influencing its bonding, structure, and even how ice forms. It is this subatomic magic that helps explain why water has so many extraordinary properties: its high surface tension, its ability to expand when frozen, and its unmatched capacity to sustain life. What seems calm and ordinary to our eyes is, at the atomic level, a realm of continuous miracles, particles leaping through barriers, vibrations humming with energy, and bonds forming patterns of infinite intricacy. From the freezing mystery of the Mpemba effect to the impossible seas of superionic ice, from the gentle artistry of snowflakes to the quantum secrets hidden within every drop, water reveals itself as one of nature's greatest paradoxes, simple yet infinite, familiar yet alien. It is both a mirror of the cosmos and the cradle of life, the storyteller of Earth's past and the silent architect of its future. Every wave, every raindrop, every crystal of ice is a fragment of the universe remembering itself, a reminder that within the most ordinary substance lies the most extraordinary truth, that existence is motion, transformation. Water, the most familiar yet enigmatic substance on Earth, is far more complex than it appears in the glass we hold or the oceans we gaze upon. At its most fundamental level, it obeys laws that stretch the boundaries of classical physics, tunneling through barriers at the quantum level in ways that seem impossible. In the strange and beautiful world of quantum mechanics, the hydrogen atoms within a water molecule can occasionally slip through energy barriers that should stop them entirely, a phenomenon known as quantum tunneling. Rather than climbing over an obstacle, the particle simply appears on the other side, moving not through physical force but through the realm of probability. This delicate and unseen behavior has profound effects on the biological and physical world, subtly influencing how water interacts with DNA and the enzymes that power life itself. Even in the cold, distant reaches of space, quantum tunneling allows water to form in conditions so frigid that normal chemical reactions should be impossible, as if the molecule carries within it the memory of paths that transcend the limits of classical matter. Within each droplet, there exists a quiet kind of magic, a reminder that the reality we inhabit is not rigid and fixed but fluid, shifting, and deeply mysterious. Despite being one of the most studied substances on Earth, water refuses to be fully understood. It breaks the rules of chemistry, defying what logic would predict. It should, according to its molecular weight, boil at far lower temperatures and sink when it freezes, yet it does neither. Its heat capacity is unexpectedly high, allowing it to absorb immense quantities of energy without drastic changes in temperature, stabilizing the climate and protecting life. Early scientists thought they could predict water's properties using simple molecular models, but water defied every attempt at reduction. Its hydrogen bonds are in constant motion, breaking and reforming billions of times per second, creating a network that behaves both orderly and chaotic at once. This strange duality is what allows our planet to exist as it does. Oceans circulate heat, weather patterns stabilize, and organisms thrive, all because of the peculiar, unpredictable nature of water's molecular dance. Without its quirks, Earth would be unrecognizable, oceans would behave differently, rain would fall differently, and the fragile balance that allows life to exist might never have emerged. Scientists have discovered that liquid water can exist not as one uniform structure, but as a constantly shifting mixture of two distinct molecular arrangements, one dense and tightly packed, the other open and loosely bonded. These two forms coexist, fluctuating within each droplet over tiny scales of time and space. The balance between them changes with temperature and pressure, and it may explain why water behaves so strangely near its freezing point. In every glass of water, regions act almost like two separate liquids, coexisting in perfect harmony. This duality challenges our entire understanding of matter itself, showing that even something as ordinary as a puddle holds hidden worlds of motion, a living landscape where order and chaos intertwine in perpetual equilibrium. As research continues, scientists now believe water may possess multiple liquid phases beyond what we can easily perceive. Under extreme conditions, water appears to separate into several distinct liquid states, each with unique internal structures. At supercooled temperatures, it may switch between a lighter, open network and a denser, compact arrangement within fractions of a second. This discovery could finally explain many of water's long-standing mysteries: why it has such an unusually high heat capacity, why it expands when frozen, and why its properties defy so many of nature's trends. What we think of as a single liquid might actually be a family of intertwined substances, layered invisibly within one another. Even after centuries of study, water continues to reveal deeper layers of complexity, proving that simplicity often conceals the most profound secrets of all. Among its many unique qualities, water also has the highest surface tension of any common liquid. Its surface, more than a mere boundary between air and fluid, acts like a delicate yet resilient film held together by invisible molecular attractions. Each molecule at the surface clings tightly to those beside and beneath it, forming an elastic skin capable of resisting external forces. This tension is what allows droplets to form perfect spheres in the weightlessness of space, what lets tiny insects and grains of dust rest delicately on its surface, and what enables water to climb upward through plant stems and form glistening beads that roll off leaves after rain. Without this invisible cohesion, dew would not sparkle, bubbles would not hold their form, and the architecture of raindrops would collapse before ever reaching the ground. At the molecular level, what we see as a smooth, reflective surface is in fact a vast, vibrating network of attractions, strong enough to hold worlds of life together through softness alone. For small creatures like water striders, this surface behaves almost like solid ground. They can walk, glide, and even dance across ponds with effortless grace, supported by a balance between gravity and tension. Their long legs, coated with microscopic hairs that repel water and trap tiny pockets of air, prevent them from breaking through the surface. Each step creates a gentle depression, a dimple that pushes back with equal force, propelling them forward with astonishing precision. Through this perfect partnership of biology and physics, they navigate their mirrored world, turning, leaping, skating, all without ever sinking. The ripples they create spread outward as waves of communication, revealing nearby movement or potential prey. In their miniature realm, gravity is not an enemy but a partner, and every motion demonstrates how even the smallest forms of life can harness the laws of nature to survive and thrive. But water's relationship with life extends far beyond its surface. Beneath the ponds where water striders glide, other creatures have evolved ingenious ways to coexist with this strange and versatile liquid. The diving bell spider, for instance, spends nearly its entire life underwater while still breathing air. It achieves this remarkable feat by weaving a dome of silk among submerged plants, then capturing tiny bubbles of air from the surface and transporting them down using the fine hairs on its abdomen. These bubbles are released into the silk structure until a shimmering underwater chamber forms, a silvery dome that serves as both home and lung. Within this fragile bubble, oxygen from the surrounding water diffuses inward while carbon dioxide escapes, allowing the spider to remain submerged for long periods without resurfacing. Inside this tiny, glimmering sphere, the spider hunts, eats, and even raises its young, an extraordinary testament to nature's ingenuity and the quiet cooperation between life and the laws of water. The physics of these systems, from the dimples that carry striders to the bubbles that sustain spiders, reveal that water's unique properties have shaped entire ways of living. They are examples of nature's inventiveness, showing how life adapts to the rules of its environment with elegance and precision. Yet the story of water does not stop at biology. It extends to chemistry and geology, shaping not only life but the very bones of the earth. Water is the most powerful solvent known, able to dissolve more substances than any other liquid. Each molecule carries a positive and a negative charge, a polarity that allows it to surround and separate particles of almost any kind. When water encounters a solid, its opposing charges gently pull molecules apart, dispersing them evenly through the liquid. This property enables nearly every essential process of life. It allows minerals to travel through soil, nutrients to circulate through plants, oxygen to move through blood, and countless chemical reactions to occur inside cells. Beyond biology, water's dissolving power sculpts landscapes over eons, eroding rock, carrying sediments to the sea, and depositing minerals to form new structures. Each drop is both an artist and a messenger, shaping continents and sustaining ecosystems with quiet persistence. Even the hardest materials yield to its patient touch, as rivers carve canyons and rain polishes stone into smooth, timeless forms. When water seeps into the cracks of rocks and freezes, it expands with enormous force, splitting even mountains apart, a process both gentle and powerful, slow yet unstoppable. Over geological time, this endless cycle of erosion and renewal transforms the planet, reminding us that what seems soft and yielding is, in truth, one of the strongest forces in nature. Water's story, from quantum tunneling to mountain carving, is one of paradox and wonder. It is at once delicate and destructive, simple and endlessly complex, ordinary and utterly magical. Within its molecules lie the secrets of existence, the birth of stars, the rhythm of tides, the balance of life. Every drop, whether falling from the sky, flowing through a river, or floating in the void of space, carries the same mysterious blueprint, a pattern of motion, energy, and connection that unites all things. To gaze into a single droplet is to glimpse the architecture of reality itself, a world where particles dance through impossible paths, where order arises from chaos. Water, the quiet sculptor of the world, shapes the very face of the earth with patience so immense that its artistry spans eons. With every drop that seeps into a crack, every stream that winds through stone, and every tide that rises and falls, it works with quiet persistence to carve beauty from resistance. These tiny fractures in the crust of the world, born from the simple expansion of ice or the gentle movement of flow, slowly grow into valleys, caves, and canyons. The Grand Canyon itself, that vast and awe-inspiring chasm, stands as a living record of water's steady labor, each stratum of exposed rock a page in the slow, patient book of time, written not with ink but with motion. Even underground, unseen rivers and streams etch labyrinthine cathedrals of limestone into existence, creating caverns that hum softly with the echoes of ancient drips. This process, though almost imperceptible in a human lifetime, reveals a fundamental truth about nature, that the greatest power often moves in silence. True strength does not always roar. Sometimes it flows gently, working with time rather than against it. Through calm persistence, water teaches that transformation does not always demand violence. It can be achieved through continuity, grace, and endurance. Yet beyond its visible artistry, water hides layers of mystery that challenge the very foundations of science. One of its quiet paradoxes is that pure water, stripped of all impurities, is not the conductor of electricity most imagine it to be. In its most pristine state, water's molecules cling tightly together with no free charges to carry current. It is only when salts, minerals, or other ions dissolve into it that water becomes a true pathway for electricity. In nature, water almost always carries these impurities, which is why it interacts so vividly with lightning, wires, and other sources of energy. But in laboratories, scientists can create water so pure that it acts as an insulator, resisting electrical flow, though only briefly, for water's purity is fleeting. It readily absorbs gases and particles from the air, reminding us that it is never truly isolated. This delicate balance between purity and conductivity is part of what makes water so fascinating. It can act as both barrier and bridge, both insulator and conductor, depending on what invisible elements mingle within it. Each droplet becomes a tiny vessel of potential, equally capable of transmitting energy, or holding it still, a dynamic equilibrium that mirrors the dual nature of existence itself. When ions drift, seawater, rich in sodium and chloride ions, is therefore a superb conductor, while distilled water, devoid of impurities, barely carries a current at all. This principle governs phenomena ranging from how marine life perceives the faint electrical fields of prey, to how thunderstorms interact with the oceans below, to how nerve signals pulse through the water-rich tissues of living bodies. Electricity in water is not chaos, it is a conversation, a dialogue between charge and motion, between the pull of energy and the flow of matter. Within this quiet exchange lies the rhythm of the earth itself, a hidden song of charge and movement that connects sky, ocean, and life. Water's mysteries deepen further when one considers that it remembers, not in the mystical sense of thought or intention, but in the molecular sense of structure and energy. When water is heated, cooled, or stirred, its molecules rearrange in subtle, temporary patterns that can persist even after external conditions return to normal. Hydrogen bonds form and dissolve in new configurations that leave behind faint traces of the liquid's past, a whisper of turbulence, a shadow of warmth, or cold. This ephemeral memory helps explain strange phenomena like supercooling, where water remains liquid below freezing temperatures, defying what physics would predict, simply because its molecular organization resists crystallization. Scientists have observed that water retains these momentary patterns before relaxing back into balance, making it one of the most responsive substances known. It reacts to vibration, pressure, and even light with extraordinary sensitivity. Each ripple, each tremor of sound or motion, leaves a fleeting signature within its structure, so that every droplet becomes a transient archive of the world it touches, recording, for an instant, the history of its own journey. Within every drop, countless hydrogen bonds link one molecule to another, holding the liquid in a delicate yet dynamic web. These faint connections arise from the uneven distribution of charge within each molecule, the slightly positive hydrogen atoms reaching toward the slightly negative oxygen atoms of their neighbors. Each bond exists only for a trillionth of a second before shifting elsewhere, creating an endlessly changing network of attraction and release. This microscopic dance allows water to store and release energy in rhythmic pulses. When bonds form, they give off warmth. When they break, they absorb it. This exchange forms the heartbeat of the planet's climate, allowing water to moderate temperature and smooth the extremes between heat and cold. The oceans act as vast batteries of thermal energy, absorbing the sun's heat by day and releasing it by night to drive winds, currents, and weather. Inside living organisms, this same principle stabilizes cells, ensuring that life can flourish within a narrow range of temperatures. Water's storage of energy is not mechanical but musical, a symphony of tiny vibrations that turn chaos into harmony and keep both planet and life in balance. All of these remarkable properties stem from something deceptively simple: the shape of the water molecule itself. Though small and seemingly straightforward, the structure of a water molecule determines everything about the world it builds. At its heart sits an oxygen atom, more electronegative than its companions, pulling shared electrons closer and creating a subtle separation of charge. The two hydrogen atoms attach not in a straight line but at an angle, giving the molecule a bent geometry that produces polarity. One side slightly negative, the other slightly positive. This polarity turns each molecule into a miniature magnet, able to attract others of its kind. From this tiny asymmetry arise all of water's most astonishing properties: the ability of ice to float, the surface tension that rounds raindrops into pearls, and the solvent power that dissolves mountains and nourishes cells. Had the molecular angle been even slightly different, the chemistry of life as we know it could never have existed. Within that perfect geometry lies balance, the quiet perfection that allows the universe to organize chaos into order. This polarity also allows water to connect and interact with everything it touches. The uneven distribution of electrical charge makes one end of the molecule attract positives and the other attract negatives, binding it to both itself and other materials. This dual ability, to cling and to connect, gives rise to water's adhesion and cohesion. It is what allows raindrops to form in the sky, rivers to climb through the pores of soil, and tears to roll smoothly across the surface of skin. It gives water its gentle strength, allowing it to stick together while also embracing the world around it. In our own bodies, this same property lets water flow through veins, tissues, and cells, carrying nutrients and signals to every corner of life. Every heartbeat, every breath depends on this invisible network of attraction. Water does not merely flow, it connects. Every droplet becomes a bridge between molecules, a bond between the living and non-living worlds, a reminder that all matter, at its essence, yearns to unite. Because of this polarity, water becomes the universal solvent, the stage upon which life performs its endless chemistry. Inside every living cell, it dissolves and separates charged particles, making reactions possible. It wraps around proteins, DNA, and other complex molecules, stabilizing them while still allowing movement and transformation. Without water's unique polarity, biological chemistry would freeze into stillness: no metabolism, no growth, no change. Instead, water allows constant motion and exchange. Nutrients dissolve and travel. Oxygen diffuses and is carried. Waste is flushed away. Life persists in a continuous cycle of reaction and renewal. It is not merely the backdrop for life's processes but an active participant in them, shaping and enabling every transformation that occurs within a living system. In the cosmic sense, it is the quiet architect of creation, the medium through which energy becomes matter and matter becomes alive. From the carving of canyons to the firing of neurons, from the gliding of spiders beneath the surface to the flow of blood through veins, water is the thread that weaves existence together. It is a paradox in motion, gentle yet powerful, simple yet infinitely complex, still yet full of hidden movement. Within its molecules lie the stories of planets and organisms alike, the pulse of weather and the breath of life. To look upon a single droplet is to see the reflection of the entire cosmos, a universe folded into a sphere of clarity, shaped by time, charged with memory, and alive with motion. Water, in its persistence and adaptability, shows us that creation is not an act of force but of patience. Water is the quiet architect of life, an invisible rhythm that flows through every breath, every cell, and every thought, shaping existence in ways both grand and delicate. Though the human body is made mostly of water, this precious element is not evenly spread throughout. It follows the logic of need and function. Muscles, blood, and the brain hold far more water than bones or fat, reflecting where energy and motion concentrate most. Inside cells, water forms the environment in which countless chemical reactions occur, enabling life's smallest engines to turn. Outside the cells, it serves as a carrier, moving nutrients inward, flushing waste outward, and maintaining a fluid connection among tissues. Even within a single organ, the concentration of water varies by layer, each adapted to its purpose, from protection to flexibility to conductivity. This uneven distribution is not imbalance, but design. It allows the body to respond dynamically to heat, movement, and pressure, to shift hydration where it is most urgently needed. The heart depends on this fluid balance to maintain blood pressure and rhythm. The eyes rely on it for clarity and comfort. The skin uses it to regulate temperature, sweating or retaining moisture in an endless dance of renewal. Every heartbeat, breath, and thought is synchronized by this fluid equilibrium, a masterpiece of nature's engineering that keeps us quietly alive. Nowhere is water's role more profound than in the brain, an organ made mostly of water and electricity. The brain's fluidity is what allows thought itself to occur. Electrical impulses surge through a maze of neurons, each signal depending on ions drifting through water-filled channels. Without this conductive liquid, the chemistry of consciousness would fail. The precise balance of water inside and outside each neuron determines how easily these electrical currents travel, shaping perception, focus, emotion, and memory. Even mild dehydration alters this balance, slowing thought, dulling reaction, and clouding mood. Yet water's work within the brain extends beyond conductivity. It cushions the delicate tissue within the skull, absorbs the shocks of motion, regulates temperature, and maintains pressure to protect its soft architecture. Every dream, idea, and memory flickers through this fluid network, a sea of thoughts sustained by the gentlest tide. In this water in motion, a living ocean of awareness contained within a fragile shell. Blood, too, is a river of water in disguise. What we call blood is a suspension of cells flowing within a liquid matrix known as plasma, which is mostly water. This plasma carries red and white cells, platelets, nutrients, hormones, and wastes in continuous circulation. Water's remarkable ability to dissolve salts, gases, and sugars allows it to deliver oxygen from the lungs to every tissue and carry carbon dioxide back for release. Its balance makes blood both fluid and thick, ensuring it flows swiftly while carrying weighty cargo. If the water content dropped too low, circulation would falter, and life's currents would slow to a halt. Just as rivers carve through rock, blood's watery flow shapes life from within, pushing through arteries and veins, nourishing billions of cells, and maintaining the delicate chemistry that sustains them. Each heartbeat becomes a testament to water's enduring rhythm, proof that existence is not a static condition but a continuous stream, an eternal current shaped by liquid balance. Deep within that current lies the code of life itself, DNA, the molecule of inheritance, which depends utterly on water. The double helix exists in a watery world so perfectly suited to it that its stability, flexibility, and replication all depend on the properties of the liquid around it. Water molecules cling to the outer edges of DNA while avoiding its inner bases, creating a natural shield that holds the spiral intact while allowing it to twist and unwind during replication. This balance of attraction and repulsion enables DNA to copy itself flawlessly, preserving the instructions that define every living thing. Without water's dissolving and rearranging abilities, genetic material could not function, could not repair itself, could not pass life forward. Every cell is a droplet of this molecular dialogue, water as solvent, protector, and messenger, holding the story of evolution in suspension. Proteins, the machinery of life, owe their shape and power to water as well. These long chains of amino acids must fold into precise forms to perform their countless tasks, from building tissue to enabling metabolism. In a dry environment, they would collapse into useless tangles, but within water, they find guidance. The push and pull between water-loving and water-avoiding regions along the protein's surface choreograph its folding, guiding it into the shape it needs to live. Once formed, the same liquid envelopes and stabilizes it, preventing decay. Without this interplay, muscles could not contract, enzymes could not catalyze, and life's chemistry would grind to a halt. Each folded protein, each functioning enzyme, is the product of a conversation between matter and moisture, a quiet negotiation that determines whether life thrives or fails. Even the shape of a cell depends on water. Every living cell behaves like a miniature balloon, its structure maintained by the pressure of water within. This internal force, known as turgor pressure, provides stability without rigidity, allowing tissues to bend, stretch, and rebound. In plants, it keeps stems upright and leaves spread toward the sun. In animals, it supports membranes and gives organs their supple consistency. Should the balance shift, cells either collapse from dehydration or burst from excess. A vivid reminder that too little or too much water alike can undo the harmony of life. Yet within this fragile range, water gives both strength and grace, shaping leaves, skin, and muscle alike with invisible hands. Nowhere is this grace more vital than in the central nervous system, where water forms a literal cushion around the brain and spine. The cerebrospinal fluid, a clear liquid composed primarily of water, bathes the brain in safety. Every step, nod, and breath sends gentle ripples through this hidden sea, absorbing impacts that would otherwise damage the fragile tissue. This same fluid circulates nutrients and removes waste, keeping the chemical balance precisely tuned. Without it, even a minor fall or sudden movement could bring harm. The fluid's existence is a quiet marvel of physics and biology, a reminder that the mind's security rests upon simple properties of water, its ability to absorb, distribute, and equalize force. This is water as guardian, cradling thought in its transparent arms. Yet the miracle continues in the smallest details, in the tears that wash the eyes and the saliva that begins digestion. Though they appear simple, these fluids are exquisite mixtures in which water is the conductor. Tears dissolve salts and healing proteins that protect the eye's surface, washing away dust and maintaining clarity. Saliva blends with enzymes that break down food, lubricating speech and swallowing. Both fluids respond subtly to emotion, fatigue, and stress, their composition shifting with mood, an intimate link between feeling and physiology. Each droplet carries a hint of both biology and emotion, proof that water flows not just through the body, but through the experience of being human. With every blink, every swallow, water connects survival to sensation, turning the mundane into something profoundly alive. But water's role is not only mechanical, it is thermal as well. It holds and transfers heat better than air, making it essential for regulating body temperature. This property allows the blood to distribute warmth evenly, preventing dangerous swings in temperature. When the body grows hot, during movement, stress, or fever, water absorbs the excess heat and carries it to the surface through sweat. As that sweat evaporates, it draws energy away, cooling the skin and maintaining balance. It is the same principle that governs the planet's climate. Oceans store the sun's energy and release it slowly, moderating extremes and sustaining life. From the smallest cell to the vastest sea, water acts as the universe's regulator, a patient keeper of equilibrium. The body's internal waters mirror the Earth's, each drop part of a larger rhythm that maintains order within chaos. Even now, with every pulse, the human body rehearses the choreography of oceans, tides, and rain. Within you, a river flows, carrying heat, light, and thought in silent procession. This endless cycle, hydration, circulation, evaporation, renewal, is the hidden heartbeat of existence. Water is not merely a resource but a force of creation, both substance and symbol of life's persistence. It holds memory, conducts emotion, and shapes form. It is the unseen poet of the body, writing every cell's story with fluid grace. To live is to flow, to balance between solidity and vapor, to exist on the shimmering boundary between land and sea. And within that balance, water is the lifeblood of the planet, the invisible thread weaving through every living system, shaping both the body and the earth itself through cycles of balance, transformation, and renewal. It is the ultimate regulator, capable of absorbing, storing, and releasing energy with elegance, maintaining equilibrium where chaos might otherwise reign. The simple process of evaporation, for instance, is a silent miracle of physics. When heat touches the skin, water transforms from liquid to vapor, carrying energy away and cooling the surface in the process. This happens because of water's high heat capacity. It takes immense energy to turn liquid water into gas. As each droplet evaporates, it draws warmth from the body, transforming discomfort into relief. This is the same process plants use to cool themselves, releasing moisture through their leaves in a quiet, shimmering exchange that protects them under the sun. Without evaporation, life in hot environments would be unbearable, perhaps impossible. Through this process, the energy of the sun, which might otherwise destroy, is converted into comfort and survival. Water's role in sustaining life is so essential that while humans can survive for weeks without food, only a few days without water lead to collapse. It is the fuel behind every breath and heartbeat, the solvent for chemical reactions, the carrier of nutrients and remover of waste, the regulator of heat, the foundation upon which all living processes depend. Fat and muscle can store energy for emergencies, but water cannot be hoarded, it must be continually replenished. Every breath, every drop of sweat, every exhale releases it into the world, and when the rate of loss exceeds replacement, life begins to falter. Dehydration thickens the blood, strains the heart, and scrambles the chemistry of the brain. Within days, systems fail, a humbling reminder that life endures only as long as the balance of water does. The same principle extends beyond individuals to the planet itself, for the earth breathes and circulates water just as we do. Each exhale, each whisper releases vapor into the air. The lungs, lined with delicate films of moisture, transform the invisible exchange of gases into a cycle of global connection. The air we release becomes part of the sky, each breath carrying tiny molecules of water back into the atmosphere. On a cold day, the mist we see as we breathe is our body's own ocean meeting the chill of the world. Over the course of a single day, a person exhales hundreds of milliliters of water, enough to fill a small cup, contributing subtly to the humidity and patterns of weather. This exchange binds all living things to the atmosphere. Each sigh and murmur participates in Earth's water cycle, connecting our lives to rain, wind, and cloud. Even in sleep, the process continues. The body releases moisture through breath and skin without notice. Each night, as we rest, vapor escapes from our lungs, and warmth from our skin turns water into air. By morning, several hundred milliliters may have vanished silently, reminding us that the act of living is never separate from flow. Hydration each morning replenishes what dreams have spent. Even in stillness, the body continues its eternal conversation with the world, a rhythm that echoes tides and rainfall. Existence itself is never static, it drifts and returns, flowing as gently as sleep. This same flow shapes the sky. Clouds, those soft, floating sculptures, appear weightless, but in truth, they are vast oceans suspended in air. A single cumulus cloud can contain hundreds of tons of water, made of countless tiny droplets too light to fall. Rising warm air supports them, creating a perfect balance between gravity pulling down and buoyancy lifting upward. When droplets merge and grow heavy, rain begins to fall, completing one loop of the planet's endless circulation. To gaze at the sky is to see water at its most ethereal, drifting between heaven and earth, waiting for gravity's call. The sight of a cloud is a reminder that balance can exist even in the tension between opposing forces. Within each droplet smaller than a human hair lies the possibility of rivers and storms, of growth and renewal. Water vapor, the invisible counterpart to liquid and ice, is the planet's most abundant greenhouse gas, a guardian of temperature, holding the warmth of the sun close enough to nurture life. It forms through evaporation from oceans, lakes, and living beings, yet its role is not merely to warm but to regulate. When vapor condenses into clouds, it reflects sunlight back into space, cooling the planet. Thus, it is both blanket and mirror, both preserver and protector. The balance between these two effects determines climate, weather, and the rhythm of seasons. Each droplet rising into the air becomes part of this vast thermal orchestra, capturing and releasing heat in tune with the turning of the earth. Water vapor is not simply a gas but a living mechanism of moderation, a subtle regulator ensuring that oceans flow, forests grow, and life persists in temperate harmony. As sunlight warms the oceans, lakes, and soils, water turns to vapor and ascends, carrying energy upward. High in the sky, when it condenses again, that energy is released, fueling winds and storms that redistribute warmth across the globe. Without this constant breathing of the planet, the tropics would scorch and the poles would freeze beyond life's reach. Every storm, every breeze, every drifting fog bank participates in this endless exchange, evaporation and condensation, heat and calm, a rhythm as old as the world itself. Water does not merely exist on Earth, it defines Earth. 97% of the planet's water lies in the oceans, covering over 2/3 of its surface in an immense, shimmering expanse. The seas absorb sunlight and distribute it through vast currents, driving winds, shaping storms, and orchestrating the planet's climate. Within their depths dwell organisms that create oxygen and anchor the food web of the entire biosphere. They reflect the colors of the sky, sculpt coasts with their tides, and hold within their depths the memory of shifting continents. To stand before the ocean is to face the ancient pulse of the planet itself. Each wave carries salt, light, and history. Each tide is a breath of the world. Yet for all this abundance, only a sliver, less than 3%, of Earth's water is fresh and fit to drink. Most of it is locked away in glaciers and polar ice, leaving only a thin fraction flowing through rivers, lakes, and underground aquifers. This small reserve sustains forests, civilizations, and countless species. Every drop that trickles from a mountain spring or falls as rain is precious, the outcome of a delicate balance between evaporation, condensation, and gravity. The cycle that renews it is ancient, driven by sunlight and wind, but fragile in the face of imbalance. To drink from a stream is to taste the rarest element of the planet's wealth, a substance at once common and extraordinary, shaped by sky and stone, sustained by the patience of the earth. Beneath the surface, most of this fresh water hides in secret. Glaciers and underground aquifers serve as the planet's reservoirs, storing centuries of liquid memory. Locked within these frozen or buried vaults is the history of rainfalls long past, of climates that have shifted, of worlds that once were. As temperatures rise, ice melts and these ancient stores begin to move, altering rivers and oceans alike, changing coastlines and weather. Thus, even in its stillness, water remains alive, shaping the future with every thaw and tide. From vapor to droplet, from stream to ocean, from body to cloud, the journey of water is the story of existence itself, a cycle of transformation that unites all living things in a single breath. It cools, nourishes, cleanses, protects, and remembers. It gives form to clouds and thought, to rivers and veins. The same molecule that drips from a leaf may one day fall as rain, freeze in an iceberg, flow in blood, or shimmer in mist. In this ceaseless movement, water becomes time itself, flowing from past to present to future in one continuous thread. Every drop is both ancient and new, both fleeting and eternal. It is the universal witness to all that has lived and all that will live, a liquid memory shaping worlds. Snowfall compressed into crystal layers forms the frozen archives of time, preserving the memory of ancient climates within every glacial fold. Underground aquifers store even more water, hidden deep beneath the crust, locked within layers of rock and soil since ancient times, their liquid hearts pulsing silently through the earth's bones. These unseen reservoirs have shaped civilizations and sustained life for millennia, feeding wells, springs, and rivers that have guided human settlement and agriculture. In some regions, these aquifers are replenished each year by rainfall and snow melt, maintaining a delicate balance between use and renewal. In others, they remain sealed relics of a vanished age, trapped since the last ice age, forming subterranean time capsules untouched by modern weather. The frozen and buried waters of our planet act as natural savings accounts, slowly releasing their stored reserves to sustain balance within the global hydrological cycle. Were all the ice on Earth to melt at once, sea levels would rise dramatically, submerging coastal cities and reshaping continents into unfamiliar silhouettes. Yet even in stillness, the planet's frozen and buried water continues to influence tides, climate, and life, quietly linking the frozen poles to the beating heart of tropical seas. Deep beneath the crust, far below human reach, lies the deepest liquid water known on Earth. This hidden ocean moves through fractures and pores in rock, heated by geothermal warmth, and held in mineral veins under immense pressure. Some of this ancient water has remained untouched since Earth's earliest days, long before the first forests breathed or the first fish swam. In those dark caverns, life endures without sunlight, nourished instead by chemical reactions, microbial colonies thriving in absolute darkness, surviving on the planet's inner energy. These deep aquifers remind us that water is not confined to surface lakes and oceans, It seeps into every corner of the planet, filling cracks, caverns, and crystalline lattices with quiet persistence. Beneath our feet lies a vast, invisible ocean, a silent twin to the seas above, proof that life's foundation extends deeper than we can ever see. Beneath Antarctica's miles-thick ice sheets, there are liquid lakes, vast and ancient bodies of water trapped under the pressure of ice and warmed by the Earth's heat below. These lakes remain unfrozen not because of warmth from above, but because of the enormous pressure exerted by the ice and geothermal energy from beneath. Some have been isolated for millions of years, cut off from sunlight and atmosphere since long before humans walked the Earth. Within their sealed waters, microbial life endures, thriving without light, oxygen, or contact with the surface. One of the largest, Lake Vostok, stretches for hundreds of miles beneath the frozen desert, its surface untouched by air or wind for eons. These subglacial lakes are time capsules, preserving clues about ancient Earth and the resilience of life. Scientists explore them not only to uncover Earth's hidden history but to imagine what forms of life might exist on other worlds where oceans lie buried beneath ice. In these secret lakes, the planet holds its oldest memories, a quiet, living heartbeat beneath frozen silence. And beyond Earth, across in the outer reaches of the solar system, far from the sun's warmth, moons like Europa, Enceladus, and Titan hide vast oceans beneath frozen crusts. These alien seas remain liquid through the combined effects of internal heat and the gravitational pull of their parent planets, which flex and knead their cores, generating warmth. Beneath ice layers miles thick, these oceans may hold more water than all of Earth's combined, suggesting that life could thrive even in the absence of sunlight. Instead of photosynthesis, such ecosystems might depend on chemical energy from interactions between rock and water, just as deep-sea organisms on Earth do. This revelation, that life may not require sunlight but only liquid water and chemistry, has transformed our understanding of habitability. Once thought to be rare, water is now known to be common across the cosmos. Europa, one of Jupiter's moons, is smaller than Earth's moon yet may contain twice as much water as all of Earth's oceans. Its gleaming surface of cracked ice hides a deep global ocean warmed by tidal forces from Jupiter's gravity. The moon's fractured crust hints at activity below, jets of frozen seawater, ridges formed by rising currents, and stains of mineral salts hinting at exchange between surface and sea. Beneath the ice, chemical reactions between water and rocky seabeds could provide energy, forming an environment similar to Earth's hydrothermal vents. No sunlight penetrates this abyss, but warmth and minerals might sustain alien ecosystems, perhaps microbial, perhaps more. Scientists dream of drilling through Europa's shell to sample its waters, searching for signs of life in its dark ocean, waiting beneath frozen light. The possibility that another world could harbor a living sea continues to inspire awe and humility, a reminder that the cosmos may be filled with hidden life, swimming in alien waters under endless night. Saturn's moon Enceladus offers even more direct proof of an active ocean world. Though small and brilliant like a pearl, Enceladus emits great fountains of water vapor and ice from cracks near its south pole. Beneath its frozen crust lies a global ocean warmed by the same tidal flexing that keeps Europa alive. Through fractures known as tiger stripes, jets of water shoot hundreds of kilometers into space, creating plumes that glow in sunlight and fall back as snow. These geysers contain not only water but salts, organics, and other molecules that suggest chemical reactions within a warm, mineral-rich sea. Some of this ejected water even contributes to Saturn's outer rings, spreading traces of Enceladus across the planet's vast domain. Watching those plumes through a telescope is like seeing an entire moon breathe, an icy world exhaling warmth, revealing motion beneath stillness. Enceladus has become one of the most promising places beyond Earth to search for life, its distant ocean whispering possibility across billions of miles. Water's story extends even farther, to the atmospheres of planets around other stars. Astronomers using space telescopes have detected water vapor in the skies of distant exoplanets by studying how starlight filters through their atmospheres. Each molecule leaves a unique signature, a faint pattern of absorption that reveals its presence even across light years. These discoveries have found water vapor on massive gas giants orbiting close to their suns, and on smaller, cooler worlds that might resemble Earth. In some, conditions could allow clouds, rain, and even oceans. The detection of water beyond our solar system has reshaped humanity's view of the universe, showing that water is not a cosmic rarity but a universal thread woven through countless worlds. Every discovery deepens the hope that somewhere, on a distant planet orbiting a quiet star, water flows beneath alien skies, nurturing life of its own. Even the vast spaces between stars are not truly empty. In interstellar clouds, cold, dark regions of dust and gas drifting through the galaxy, water molecules form on the icy surfaces of tiny grains. Though incredibly diffuse, these clouds contain enough vapor, if gathered, to fill oceans many times over. When newborn stars ignite within them, their heat releases the frozen water, sending it into space where it becomes part of forming planets and comets. Every drop of water on Earth, every river and raindrop, may trace its origins to these cosmic nurseries. The fact that water exists even in the coldest corners of the universe reminds us that creation is ongoing, that the chemistry of life is written into the stars themselves. And as these processes continue, comets carry this ancient water across the solar system. Comets are frozen messengers from the dawn of time, relics of the solar system's birth that still contain the original water and organic material from that era. Made of rock, dust, and ice, they travel along immense orbits that bring them close to the sun and then fling them back into deep space. When sunlight warms them, their frozen surfaces vaporize, creating glowing tails that stretch for millions of kilometers. Each time a comet passes the sun, it releases part of its ancient cargo, scattering water, dust, and the building blocks of life across space. Some of that material eventually finds its way to planets, perhaps even seeding early Earth with the water that would one day form its oceans. In this way, comets are both archives and couriers, icy travelers that bridge the gap between stars and worlds, carrying within them the story of water's cosmic journey. From interstellar clouds to frozen moons, from buried aquifers to our own breath, water threads through every scale of existence. It is the silent witness of creation, memory, and transformation, the same molecule that falls as rain, flows as rivers, freezes as glaciers, and drifts as vapor between the stars. Its persistence defines life, connects worlds, and reminds us that everything alive shares one timeless rhythm, the endless, patient flow of water through light and darkness. Water, the essence of life, has a story that begins long before Earth itself, born in the cold depths of space where comets and asteroids carried frozen molecules across the dark, silent reaches of the solar system. Scientists believe that much of our planet's water may have arrived this way, not born here, but delivered as a gift from afar. Billions of years ago, when Earth was still young, its surface was a molten inferno, scorched and dry, ceaselessly bombarded by debris from the formation of the planets. In that chaotic time, collisions with icy comets and water-bearing asteroids brought not just destruction but renewal, carrying with them the building blocks of oceans and perhaps even the seeds of life itself. Each impact vaporized ice into steam, which later cooled and condensed as the planet's surface solidified, giving rise to the first shimmering oceans. This transformation from a blazing world of rock to a blue sphere of seas took millions of years, a slow, patient alchemy written in isotopes, the chemical fingerprints left behind in ancient meteorites that mirror the composition of Earth's waters today. These isotopes whisper of an age when the universe itself rained upon the Earth, turning chaos into calm and dust into oceans. Even now, some meteorites that fall to Earth hold tiny veins of water-rich minerals, microscopic relics of that cosmic rain. When scientists break these stones open, they find evidence that liquid water once moved through the asteroids they came from, proof that long before our planet existed, water had already shaped other worlds. Each fragment becomes a time capsule, holding the frozen memory of how the solar system evolved, revealing that water has been present everywhere since the dawn of planetary formation, woven into the very dust that built the stars. Every drop of our oceans is ancient beyond imagining, part of a cosmic cycle stretching back to the birth of worlds. Mars, our dusty red neighbor, holds its own watery secrets. Once upon a time, that now barren planet may have been alive with lakes, rivers, and perhaps even shallow seas. Its surface today bears the scars of water's vanished presence: dry riverbeds meandering through craters, vast deltas carved by floods, and minerals that could only have formed in the presence of liquid water. Rovers have found clay and sulfates, minerals shaped by ancient rains, telling a story of a planet that once breathed moisture and warmth. For hundreds of millions of years, Mars may have enjoyed a thicker atmosphere that kept its waters from escaping into space, allowing a climate mild enough for lakes to glimmer under a softer sun. But over eons, the planet's magnetic field weakened, solar winds stripped away its atmosphere, and with it went the water. Today, what remains lies hidden as frost and subterranean ice, sleeping beneath a desert sky. At its poles, gleaming white caps of frozen carbon dioxide and water ice expand and shrink with the Martian seasons. In winter, carbon dioxide gas freezes from the air, creating a thick blanket of dry ice that can be meters deep. When summer returns, sunlight vaporizes the frozen gas, revealing the underlying ice and driving fierce winds and dust storms across the planet. This rhythmic breathing of ice and vapor acts as Mars's heartbeat, a pulse that has endured for billions of years. Beneath those polar layers lies an ancient archive, a frozen diary preserving the story of Mars's lost oceans, a record of the time when its red sands once shimmered blue. The greatest canyon on Mars, Valles Marineris, stretches for thousands of kilometers and plunges deeper than Earth's Grand Canyon. And though volcanic forces helped shape it, the earliest marks were carved by flowing water. The minerals within its walls testify to rivers that once cut through stone, etching their memory into the planet's crust. Even in its silence, Mars remembers, the ghost of its waters lingering in every dried-up channel, a monument to what once was, a world that, like Earth, could have known the touch of rain. Venus, too, bears traces of a lost oceanic past. Though it now blazes with heat and sulfuric clouds, it may once have been Earth's twin in both size and serenity, with calm seas and blue skies. But as the sun's brightness increased over time, Venus's oceans began to evaporate. Water vapor, a powerful greenhouse gas, trapped even more heat, leading to a runaway effect. The planet grew hotter and hotter until its seas boiled away completely. Ultraviolet radiation from the sun split the remaining water molecules, letting hydrogen escape into space while oxygen reacted with rocks below. What was left behind was a dense, toxic atmosphere of carbon dioxide and sulfuric acid, a suffocating veil that turned the planet into a blazing inferno. Yet, high in Venus's upper clouds, scientists have detected faint traces of water vapor, ghostly remnants of the oceans that once graced its surface. They are whispers of what could have been, a sister world that, had fate been slightly different, might have mirrored our own blue planet. Venus is a warning written in the Even Earth, with its seemingly endless oceans, is not immune to change. Our planet is slowly, quietly losing water to space. At the edge of our atmosphere, where the sky fades into the void, sunlight breaks apart water molecules into hydrogen and oxygen. The light hydrogen atoms, barely tethered by gravity, escape into space, drifting away forever. It happens invisibly and constantly, thousands of atoms slipping past Earth's magnetic shield every second. Though the loss is tiny, over geological time it adds up, a reminder that even something as vast as the ocean is not eternal. The process has already stripped Mars of its seas and likely helped dry Venus's skies. Earth's magnetic field and thick atmosphere protect us, keeping most of our water bound, but the escape continues like a slow breath outward, an unseen exchange between planet and cosmos. Space itself, in its silence, drinks from our oceans one invisible sip at a time, carrying away the faint memory of storms, rivers, and tides. It's a humbling thought, that the oceans we take for granted are slowly being undone, atom by atom, into the emptiness from which they came. Meanwhile, the oceans themselves are changing in another, quieter way. They are growing salter. Rain and rivers constantly wash minerals from the land into the sea. As water evaporates from the surface to form clouds, it leaves those dissolved salts behind. Over hundreds of millions of years, This process has slowly increased the ocean's salinity, shaping marine chemistry, influencing how shells form, and guiding the movement of currents that regulate our planet's climate. Though the change is gradual, it is ceaseless. Some parts of the ocean, near melting ice or heavy rainfall, become fresher. Others, under hot sun and strong winds, grow salter. The sea is always in motion, always balancing, always breathing. Every drop carries within it the memory of mountains long since worn away, dissolved into invisible ions that drift endlessly through the tides. Each grain of salt in the ocean once belonged to a stone high on a mountaintop, born of rain that fell ages ago, seeping into cracks, dissolving minerals, and carrying them to the rivers below. Rivers carried them onward to the sea, where they would remain forever, for when seawater evaporates, only pure vapor rises, leaving the salts behind to accumulate over eons. This endless cycle of dissolution and deposition has given the oceans their taste and texture, a slow, geological alchemy that turns mountains into minerals and minerals into memory. The salt that lingers on your lips after a swim is the echo of ancient rain meeting stone, of rivers carving continents, and surrendering their essence to the deep. Every crystal of sea salt tells a story of Earth's eternal dialogue between land and water, a conversation that began with the first storms to fall upon rock and continues today in every breaking wave. From the comets that carried water across the void to the rivers that carved valleys into continents, from the vanished oceans of Mars and Venus to the eternal tides of Earth, the story of water is the story of change, of endurance and loss, creation and transformation. It reminds us that nothing, not even the sea, is forever still. The same molecules that drifted through interstellar dust billions of years ago now flow through our veins, fall as rain, and rise again as vapor into the endless cycle of renewal. Water connects us to the stars, to the planets that might have been, and to the future worlds yet to form. It is the silent witness to everything, a memory of the cosmos itself, forever moving, forever. The taste of seawater is the memory of continents dissolving, grain by grain, as waves endlessly break upon the shore. Each crashing surge carries within it the ghost of stone, a whisper of mountains long since surrendered to time. The land and the sea are not opposites, but partners in an eternal conversation, erosion and renewal speaking back and forth through the rhythm of tides. Under immense pressure, water transforms into something almost otherworldly. In the deep ocean, where sunlight never penetrates, and the weight of the world bears down from above, water behaves in ways impossible at the surface. It becomes a powerful solvent, capable of dissolving metals and minerals far beyond what seems natural. Inside the cracks of Earth's crust, superheated water seeps through the rock, leaching elements, and carrying them upward in hidden veins. When this water finally vents through fissures on the ocean floor, it cools rapidly, precipitating minerals that form shimmering deposits of crystal and metal. Entire ridges of the seafloor are shaped by these unseen reactions, water acting as sculptor, messenger, and alchemist, bearing whispers of Earth's fiery heart to the cold depths above. At these deep sea vents, where jets of mineral-rich water gush into near-freezing darkness, temperatures can exceed hundreds of degrees, yet the liquid does not boil because of the crushing pressure that surrounds it. As the scalding water escapes into the icy sea, it cools, and the dissolved metals and sulfur solidify, building towering chimneys of black or white mineral smoke. Around these strange structures, life flourishes without a trace of sunlight. Bacteria feed on the chemicals exhaled from Earth's interior, creating the foundation of ecosystems teeming with worms, crabs, and ghostly fish. These vents are oases of life in a world of eternal night, a bridge between the molten core and the frozen abyss. Many scientists believe that life itself may have begun here, in the hot, mineral-rich waters of ancient hydrothermal vents. In these primal cauldrons, chemistry found a foothold. Heat and minerals provided the energy that sunlight could not, and within the tiny cavities of vent chimneys, simple molecules collided, merged, and began to organize into complex patterns. In this shadowy realm, carbon compounds may have learned to store and use energy, the first flicker of what we now call life. The discovery of entire ecosystems thriving without sunlight shattered our understanding of biology. It proved that life does not depend solely on the warmth of the sun, but on balance, on the meeting of water, heat, and chemistry. Perhaps in those ancient vents, nestled within stone pores, life began as quiet reactions in the dark, slowly learning to grow, to divide, to endure. Every breath we take today may trace its ancestry back to those invisible reactions deep beneath the sea, the planet's own heartbeat teaching matter how to live. Water's behavior is full of miracles like this, small physical quirks that make life possible. One of the most extraordinary is its density. Most substances grow steadily denser as they cool, but not water. Instead, it reaches its maximum density just above freezing. This simple detail determines whether lakes live or die each winter. As a lake cools, the coldest water, being less dense, floats on top, forming a layer of ice that insulates the water below. Beneath this frozen skin, life continues. Fish drift slowly, plants release oxygen, and microorganisms persist in near-silent darkness. Were water not to behave this way, entire lakes and ponds would freeze solid from the bottom up, extinguishing all aquatic life each year. Instead, nature's geometry saves them. The angle of hydrogen bonds in water molecules ensures that ice expands, growing lighter as it freezes. It is a subtle shift, only a few degrees wide, but it decides whether a lake becomes a tomb or a cradle. When winter settles in, the cold winds still the surface of lakes and ponds. Ice blooms slowly across the top, sealing in the world beneath. Yet under that lid, life endures. The dense water at a few degrees above freezing sinks to the bottom, keeping the depths liquid while ice thickens above. The frozen layer becomes both a shield and a blanket, protecting life from the worst of the cold. Tiny cracks in the surface allow oxygen to pass, while the currents below remain alive, faint but steady. If water were like any other liquid, none of this would be possible. Every winter would erase life, and every spring would begin from nothing. But instead, lakes sleep rather than die, waiting for the thaw. When warmth returns and the ice melts, the process reverses. Winds stir the surface, and the water layers mix again, distributing nutrients and oxygen from top to bottom. This phenomenon, called turnover, happens twice each year in many lakes, in spring and autumn, a quiet renewal that keeps ecosystems breathing. Without it, deep waters would become stagnant, starved of oxygen, unable to sustain the vibrant networks of life that depend on them. Turnover ensures that even the stillest lakes are never truly still. They pulse gently with the seasons, each cycle an echo of planetary rhythm. The movement of water above the surface tells its own story of energy and motion. When we watch waves roll toward the shore, it seems as though water is traveling across the sea. But in truth, it is not the water that journeys forward, it is energy. Each molecule of water traces a small circular path, rising and falling, moving forward and back as the wave passes. What travels across vast distances is the pulse, the energy transferred from distant winds, storms, and seismic tremors. This delicate dance allows the sea to carry messages across continents. The shape and rhythm of waves tell the tale of faraway winds and invisible storms, the rotation of the earth, and the pull of the moon. The ocean's surface is never silent. It hums with energy, whispering the memory of tempests thousands of miles away. A single wave breaking upon the shore may have been born in a storm beyond the horizon weeks earlier, its long voyage shaped by the curvature of the earth and the gravity of the moon. To stand at the edge of the sea and watch waves is to witness the planet's heartbeat, energy in its purest form, repeating endlessly, steady, patient, and eternal. Far from the coast, in the deep open ocean, waves called swells can travel for thousands of miles without breaking. Born from powerful storms, they roll in smooth, rhythmic sequences, their energy carried forward by gravity and inertia. These swells cross entire ocean basins, their surfaces polished and even, their rhythm steady as breathing. To sailors, they are both beautiful and ominous, long, rolling reminders of storms long past. A ship can rise and fall with their motion even in calm weather, the ocean still remembering tempests that ended far away. Only when these waves approach land does their energy finally meet resistance. The lower part of the wave drags against the seabed, slowing down, while the upper part continues forward, rising higher and steeper until it curls, breaks, and releases its strength in a final burst upon the shore. Yet for most of their journey, they do not break at all. They are the long breath of the planet, the traveling memory of wind and gravity, the timeless motion that unites continents through invisible threads of force. And beneath this great theater of waves lies the even deeper rhythm of tides, the daily heartbeat of Earth's water. Every coastline feels their pull, the invisible hands of the moon, and the sun drawing the oceans into vast bulges that shift with the turning of the world. Tides are more than just rising and falling water, they are the pulse of our planet's gravitational dance. Twice each day, the sea reaches for the sky and then retreats, a breathing of the planet that has shaped coastlines, guided migrations, and influenced civilizations for millennia. The tides fill estuaries and empty them again, carry nutrients into shallows, and create vast mudflats that sustain entire ecosystems. Their rhythmic pull drives currents that mix the oceans, redistributing energy and life across the globe. For creatures that live between land and sea, tides are a law of existence. They dictate feeding, breeding, and movement. Birds wait for the ebb to hunt, crabs burrow in sync with the moon, and coral reefs bloom and rest to the rhythm of celestial gravity. To stand on a beach at low tide is to witness the earth itself breathing, the water drawn outward, the seabed exposed, the air filled with the scent of salt and life. When the tide returns, it erases all footprints, as if reminding us that everything on this planet moves in cycles. Together these movements, the waves, the tides, the turnover of lakes, and the silent venting of heat from the seafloor, form one great system of circulation. They connect the sky, the sea, the deep earth, and life itself in a continuous dialogue. Water dissolves stone and carries its memory to the ocean, where it mixes with minerals from the planet's fiery heart, where it freezes and melts with the rhythm of the seasons, and where it dances in the gravitational music of the moon. It is never still. It carries heat from the equator to the poles, salt from rivers to seas, whispers of magma from the core to the crust. It sculpts mountains, feeds valleys, and gives voice to the wind. Every droplet holds within it a trace of ancient rain, of vanished glaciers, of stars long dead that once forged the oxygen and hydrogen now bound together as water. The sea's saltiness, its rhythm, its chemistry, all of it is history written in liquid form. To taste seawater is to taste time itself, the memory of mountains eroded to sand, of continents broken and rejoined, of the endless cycles that make our planet alive. And so, whether locked in ice, flowing through rivers, or rising as vapor to touch the stars, water remains the same, a restless The moon's gravity pulls at the vast oceans of Earth, shaping the daily tides that never rest and never lose their strength. Across the globe, the moon's subtle yet powerful tug stretches the planet's waters into two immense bulges, one facing the moon directly and the other on the opposite side of the world. As Earth rotates, different coastlines pass beneath these bulges, creating two high tides each day, followed by two lows, a constant and gentle rhythm that has echoed since the earliest ages of the planet. The moon's pull is strong enough to move entire seas, yet so delicate that it feels like the whisper of the cosmos itself brushing against our world. The sun joins this celestial dance, amplifying tides during full and new moons, when both bodies align, and softening them during quarter phases when their gravitational pulls compete. This intricate balance of forces shapes the breathing of the coastlines, guiding the rise and fall of waters that sustain countless forms of life. The tides don't simply move the sea, they shape ecosystems, influence climates, and even affect the rotation of the planet itself. The constant friction caused by tides gradually slows Earth's spin, lengthening our days by fractions of a second over eons. Every tide that washes ashore is a living trace of the relationship between Earth and its luminous companion, a visible manifestation of an invisible bond that links the two worlds in gravitational harmony. Yet this influence extends far beyond the ocean. The moon's pull also creates subtle tides in the solid crust and in the atmosphere above. The ground beneath our feet rises and falls by mere centimeters each day as the entire planet flexes gently to the same cosmic rhythm. Even the air participates, forming slight pressure bulges that sweep around the world, invisible yet measurable, moving in sync with the moon's orbit. These delicate variations can influence everything from the triggering of minor earthquakes to the flow of magma deep within the Earth, and even the precision of satellites tracing their paths through the sky. The planet as a whole breathes with the sea, each layer, air, water, and rock, resonating to the same ancient gravitational song that unites them all. From the vast pull of the tides to the smallest drop of dew, water is never still. It moves in endless circulation through air, land, and sea, connecting every living thing to the rhythms of the world. The hydrological cycle, the planet's eternal heartbeat, is a grand and continuous journey. Sunlight lifts water from the ocean as vapor, forming clouds that drift across the sky. When they cool, the vapor condenses and falls as rain, feeding rivers, lakes, and soil, eventually returning to the sea to begin again. Every molecule of water on Earth participates in this timeless cycle, rising, falling, freezing, melting, and flowing in an endless loop that maintains balance between the continents and the oceans. The water in your glass today may once have fallen as rain upon ancient mountains, frozen into glaciers during the ice ages, or trickled through the roots of primeval forests millions of years ago. Every living being is a vessel through which this water passes, briefly joining the journey before moving on. The same molecules that once fell upon the backs of dinosaurs or surged through the gills of prehistoric fish may now flow through your veins, sustaining your life as they have sustained countless others before you. When you breathe, sweat, or shed a tear, those molecules return to the air, ready to rise again and continue their voyage through time. There is no new water, only transformation, matter endlessly recycled through the cosmic machinery of life. Every heartbeat and breath is part of this great flow, linking us to oceans, clouds, and rainbows, to the depths of ancient seas and the mists of tomorrow. A single raindrop's journey is rarely direct. Some fall upon mountainsides and rush quickly to the sea, while others begin odysseys that last thousands of years. Many soak into the ground, sinking deep into underground aquifers that creep through layers of rock at the slowest imaginable pace. Others freeze into glaciers, imprisoned in crystalline stillness for millennia before melting again to rejoin the rivers of the world. Scientists studying isotopes in groundwater have discovered droplets that first fell during the last ice age, their long descent finally ending in springs that bubble to the surface today. Each raindrop is a traveler through time, following its own winding path across the planet. When it finally reaches the sea, it merges once more with the collective flow, completing a journey that has no real beginning or end, only pauses in an eternal circulation that connects all living worlds. At the poles and on high mountains, snow layers compress into ice, trapping bubbles of air and dust along with the ancient water itself. These frozen archives preserve the memory of the planet's climate across thousands of years, capturing within their layers records of storms, volcanic eruptions, and shifting atmospheres. Scientists who drilled deep into these glaciers read the past like a history written in ice, learning how the Earth once breathed and changed. Some of the frozen water they uncover has not melted since before the rise of civilization. When it finally does melt, the molecules are released to continue their ancient voyage, joining clouds and seas once again. The slow melting of ice is more than a physical change. It is the awakening of history, each drop a messenger from a colder, quieter world whispering of ages long past. Water does not only move, it nourishes. As it seeps through soil, it dissolves minerals that feed roots and trees, carrying essential nutrients upward to sustain life. Rivers gather the remains of leaves, bark, and soil, delivering them downstream to feed fish, algae, and plants in faraway deltas. Even in deserts, where water is rare, a single rainfall can awaken a hidden universe of seeds and microorganisms, bringing the land briefly to life before fading again into silence. In this way, water acts as the great connector, linking ecosystems and transforming death into renewal. The rain that falls upon a forest may one day flow into an estuary, carrying minerals and carbon that nurture new growth elsewhere. This continuous transfer of nutrients sustains diversity across the planet, creating a network of life that stretches from mountain peaks to coral reefs. Without the motion of water, ecosystems would stagnate and decay. Instead, the planet thrives because of this endless exchange. Each The clouds that deliver rain are themselves sculptors of the earth. Tiny particles of dust, salt, or pollen act as seeds around which vapor condenses, forming droplets that gather until gravity pulls them back to the ground. Each storm, though fleeting, participates in a slow, monumental transformation. Over ages, rain wears down mountains, carving valleys and carrying sediments to the sea. The continents themselves are shaped by this patient erosion, their bones softened and remade by water's persistence. The rivers that flow from rain sculpt fertile plains and floodplains that cradle civilizations. Every drop contributes to the long artistry of the planet, the endless reshaping of stone into soil and soil into life. A raindrop that falls on a barren hill today may one day nourish a forest centuries from now, or lie deep beneath a desert, waiting for another era. Clouds, in their soft and drifting beauty, are builders as much as they are poets of the sky, bridging air, stone, and life through the patient alchemy of condensation and fall. When we look upon a lake or an ocean, we often believe it is blue because it mirrors the sky above. Yet water has its own subtle color, born from the way it absorbs light. Red and yellow wavelengths vanish first as sunlight enters the depths, leaving only blue to scatter back to our eyes. In deeper waters, this effect creates the ocean's iconic hue, while near the shore, sediments and plant life shift it toward green or gray. Water, in essence, carries the memory of light within it, reflecting the heavens while absorbing the sun's touch into its body. Its transparency conceals its power, for beneath that calm surface lies an element capable of carving canyons, raising clouds, and sustaining the entirety of life. The story of water is the story of Earth itself, restless, cyclical, and alive. It binds continents, sculpts coastlines, fills the air with mist, and forms the blood of all living things. It moves through time with patient persistence, wearing down mountains, feeding forests, and carrying the songs of the sky into the deep. From the tides that pulse under the moon's gaze to the raindrops that rest for millennia in ice, every movement of water is a part of a single, unified breath of the planet. It is a force of connection, between worlds, between ages, between every creature that drinks, breathes, or dreams. The next time you feel rain upon your skin or see the tide pulling gently at the shore, remember that you are touching the oldest traveler of all, one that has seen the birth of continents and the dawn of life, and that continues, and water, the substance so familiar that we often overlook its wonders, is a masterpiece of physics and perception, a living lens through which we glimpse both the sky and the soul of the earth itself. The color of water, for instance, is not a fixed hue but a living dialogue between light and depth, reflection and absorption, matter and energy. Pure water, in its essence, absorbs the red parts of sunlight more effectively than the blue, allowing the cooler tones to scatter back to our eyes. This scattering, gentle yet precise, explains why the sea and deep lakes shimmer in endless shades of blue. In shallow water, this effect is faint, as sunlight's warm colors still dance through, but as the depth increases, the red and orange light vanishes, leaving behind the pure, cold blue that deepens into an almost ethereal azure. The presence of sediment, algae, and dissolved minerals alters this natural palette, painting the oceans in hues of turquoise, green, or even brown, depending on the microscopic life within. Thus, every stretch of sea tells a different story of light, chemistry, and life, a living map of reflection and absorption. To gaze into water is to see both the heavens mirrored above and the molecular architecture of life below, a seamless merging of the spiritual and the physical. Deep water appears blue precisely because it absorbs the red light first. Sunlight entering the ocean fades gradually through the spectrum, red, orange, yellow, until only blue remains to illuminate the depths. Within just a few meters, nearly all warm colors are gone, leaving the blue wavelengths to scatter and glow, giving the illusion that the ocean itself is luminous from within. Fish, corals, and countless marine creatures have evolved to live in this filtered world of cool tones, their pigments adapted to capture or reflect the scarce blue light. Divers who descend beneath the waves often notice that red objects, even their own skin, lose their color entirely, turning pale or gray as the deeper layers swallow the warmer wavelengths. This striking transformation reveals a profound truth. color is not inherent to objects but born from the interplay between light and matter. The ocean's radiant blue is thus an illusion, a poetic collaboration between photons and molecules, a daily miracle where physics becomes art. Yet water holds more secrets still. Under ultraviolet light, pure water emits a faint luminescence, a glow so subtle it is almost invisible. This phenomenon arises from the interaction between energetic UV photons and the molecular bonds within the liquid, a whisper of light that reveals the quiet conversation of atoms. Impurities, organic matter, or dissolved minerals can change the hue or brightness of this glow, making it a tool for this delicate shimmer, vanishing the instant the light source is removed, is a fleeting display of quantum behavior, a reminder that even the simplest substance conceals layers of complexity invisible to the naked eye. The same principle allows researchers in astrophysics to detect water on distant worlds, in icy comets, or on barren moons, where the faint fluorescence signals the presence of molecules essential for life. Thus, even a still drop of water carries within it the ancient memory of the universe's first illumination, a residue of cosmic energy still echoing through time. But perhaps the most magical of water's light tricks belongs to life itself. In certain warm coastal waters, especially on calm, moonless nights, the sea comes alive with bioluminescence, a natural fireworks display performed by microscopic organisms called dinoflagellates. When disturbed by movement, such as the stroke of a swimmer's arm or the ripple of a passing fish, these tiny beings emit flashes of blue-green light through a chemical reaction involving luciferin and oxygen. The result is breathtaking: waves that shimmer like molten stars, glowing trails that follow every ripple, boat, or fish, transforming the ocean into a dreamscape of living light. For the organisms themselves, this glow is not for beauty but survival, a sudden flash meant to startle predators or attract mates. Yet to us, it is pure wonder, a glimpse of biology transformed into poetry. Beaches that experience this phenomenon, such as the bays of Vieques in Puerto Rico or the luminous lagoon of Jamaica, become stages for nature's quiet theater, where each gentle splash ignites the water in radiant blue. In those glowing waves, it feels as though the sea is breathing light, whispering to the night sky that life itself is luminous. The stillness of these bays, the density of their plankton, and the calm of their waters combine to create a perfect canvas for light, transforming ordinary movement into living radiance. It is as though the ocean remembers the stars it once reflected, now recreating them within itself. Water, however, does not only carry light, it carries sound too, and in extraordinary ways. Because water molecules are closely packed, vibrations pass through them far more efficiently than through air, allowing sound to travel nearly 4 times faster beneath the surface. The underwater world, contrary to its reputation for silence, is alive with clicks, songs, groans, and murmurs, a vast symphony of motion and life. Whales and dolphins use this clarity to communicate across enormous distances, sending calls that can echo for hundreds or even thousands of miles. Submarines and scientists harness this property to map the seafloor, locate schools of fish, or listen to the rumblings of distant earthquakes. Yet this same efficiency also makes underwater noise pollution a major threat, as the constant hum of ships and sonar can disrupt the natural communication of marine animals that rely on these sounds for survival. In the dark deep, where light fades entirely, sound becomes the sense of vision, a living network of vibration that connects everything to everything else. Among all marine sounds, none are more haunting or profound than the songs of whales. Some species, like blue or humpback whales, produce low-frequency calls that can travel across entire ocean basins, moving through layers of water with astonishing precision. Each whale species has its own distinct language, patterns of moans, pulses, and melodies, which may serve to attract mates, signal migration routes, or express social bonds. A single blue whale call can be louder than a jet engine, yet it resonates not as noise but as music, slow, deep, and impossibly vast. What's more, scientists have observed that whale songs evolve over time, changing their melodies and rhythms as if composing new verses in an ancient, oceanic symphony. Listening to them is like hearing the voice of the planet itself, vast, resonant, and endlessly alive, a reminder that communication began long before words were ever spoken. The ocean's acoustics are shaped by an extraordinary structure known as the deep sound channel, a narrow layer where temperature and pressure balance perfectly, allowing sound to travel immense distances without losing energy. Within this natural waveguide, sound waves bend back toward the layer instead of dissipating, becoming trapped in an invisible corridor that encircles the globe. Whales instinctively use this layer to communicate across continents, while submarines exploit it for stealth and long-range listening. The discovery of this channel revealed that the ocean is not an empty expanse but an intricate, resonant body, an instrument whose notes travel endlessly through its liquid corridors. It is a place where sound itself finds a kind of horizon, a realm where physics and music converge. Yet for all its grace, the sea is also a domain of immense pressure, a world where each additional 10 meters of depth adds the weight of an entire atmosphere. At just 100 meters below the surface, the pressure is 10 times greater than at sea level, enough to crush air pockets and distort metal. Deep-sea creatures survive this unimaginable force only because their bodies contain no trapped gases. Their tissues are perfectly balanced against the surrounding water. For humans, exploring these depths requires technology of extraordinary strength, submersibles built like titanium fortresses to withstand the crushing embrace of the abyss. In this world, where darkness reigns and silence hums with invisible vibrations, life persists in strange and beautiful forms: translucent fish, luminous jelly, slow-drifting giants that glow softly in the black. Here, water's physical laws shape the architecture of existence itself. It absorbs, reflects, carries, glows, and presses, a substance so ordinary that we forget it defines the world. It is both mirror and medium, a silent sculptor of color, sound, and form. To understand water is to glimpse the blueprint of life and the poetry of the cosmos. It is the skin of the Beneath the serene surface of the oceans lies a world governed by immense and invisible forces, where pressure builds relentlessly and life itself is tested against the crushing weight of the planet. The deeper we descend, the more unforgiving this environment becomes, with each 10 meters of depth adding another atmosphere of pressure, a force capable of collapsing steel and distorting even the hardest materials. At the deepest point of the ocean, the Mariana Trench, the pressure is over 1,000 times greater than that at the surface. Here, a steel sphere would implode instantly, yet delicate forms of life still thrive in this abyss of silence and darkness. The water compresses slightly under this strain, altering the way sound moves, slowing chemical reactions, and changing the structure of minerals themselves. Few human-made submersibles have ever reached these depths, their walls engineered to withstand thousands of tons of pressure, their lights slicing through an alien landscape that exists in perpetual night. When those lights are turned off, explorers encounter a darkness so complete it seems to erase all sense of direction, yet even here, where temperatures hover just above freezing and light never penetrates, life endures. The ocean floor in this place is covered with fine sediment, shaped by the slow grind of tectonic movement, a world both ancient and alien. Life at such depths defies our expectations, proving that existence is not confined by comfort but defined by resilience. Microbes live in the deepest sediments, feeding on the faint chemical traces that drift down from the world above or seep upward from volcanic fissures below. These microscopic beings endure conditions that would annihilate most known life, surviving through biochemical adaptations that repair their DNA when it shatters under pressure. Some reproduce only once every few centuries, their metabolism slowed to near stillness, yet they persist, maintaining the delicate balance of nutrients that sustain the trench ecosystem. They demonstrate that even in the absence of sunlight, heat, and normal energy sources, life finds a way. In their slow, patient existence, these microbes whisper of possibilities beyond Earth, suggesting that similar organisms could inhabit the icy oceans of Europa or the subsurface seas of distant moons, thriving in perpetual night. Even more astonishing are the extremophiles that live not in cold but in heat, microorganisms that survive in superheated waters around volcanic vents and hydrothermal springs. These vents, where seawater seeps through the crust and emerges at temperatures exceeding boiling, form shimmering oases of life in an otherwise barren deep. Protected by immense pressure that prevents the water from vaporizing, these microbes endure conditions that would instantly destroy most known species. Their enzymes, proteins, and cell membranes are adapted to remain stable in such extremes, allowing them to metabolize sulfur, iron, or methane instead of sunlight. Scientists study them as living analogues for how life might have first arisen on the early Earth, or how it might exist elsewhere in the cosmos. These organisms redefine the boundaries of biology's imagination, showing that habitability is not a narrow zone of comfort, but a vast spectrum of endurance. Even at temperatures approaching the boiling point, water remains a cradle for life, a paradoxical element that can both destroy and preserve. Where it scalds, it also sustains. Where it sterilizes, it simultaneously nurtures new beginnings. In contrast to the heat dwellers, some organisms survive at the opposite extreme, frozen in solid ice for thousands of years. Within glaciers and polar permafrost, tiny life forms rest suspended in timeless stillness, encased in microscopic pockets of liquid brine that remain unfrozen between ice crystals. Here, life continues at the faintest hum of metabolism, drawing minimal energy from minerals or from the dim, filtered sunlight that seeps through layers of snow. Some of these microbes have been revived after tens of thousands of years entombed in ice, instantly returning to life when thawed. They are living records of endurance, biological echoes of ancient eras that help scientists imagine what life might be like beneath the frozen crusts of Europa or Enceladus, moons that hide vast oceans beneath their ice. Even in stillness, water remains the enabler, the keeper of potential, the element that allows existence to pause without perishing. Within each frozen droplet lies a story of persistence, a quiet defiance of time itself. Water, unlike any other known substance, exists naturally on Earth in all three states of matter, solid, liquid, and gas, and moves seamlessly among them. This fluidity is not only a physical marvel but the heartbeat of our planet's systems. The frozen mountaintops feed rivers as ice melts in spring. Those rivers flow to the seas, from which evaporation lifts vapor into the sky, forming clouds that return as rain. Through this continuous exchange, water sculpts landscapes, drives weather, and sustains life. Without its ability to transform, the world would lack storms, seasons, and the endless renewal that makes life possible. It is an alchemist, capable of turning rock into valley, vapor into rain, and stillness into motion. Its transformations unite the physical and the poetic, binding the Earth's Yet the oceans we see are only the surface of Earth's true water story. Deep within the planet's mantle lies a hidden ocean, an enormous reservoir of water locked within minerals, not as liquid, but as hydrogen and oxygen atoms bound inside crystalline structures. When the mantle's rocks melt or shift through tectonic activity, this water is released as vapor, feeding volcanic eruptions and replenishing the atmosphere. Scientists estimate that the volume of this subterranean water may equal, or even exceed all of Earth's visible oceans combined. This buried moisture influences the planet's geology, lubricating the movement of tectonic plates, aiding in the formation of continents, and acting as a stabilizing force for the planet's long-term climate. It is a silent regulator, a deep pulse of the hydrologic cycle that operates on a timescale of millions of years. Its discovery transformed our understanding of Earth, revealing that the blue oceans above are only one layer of a vast, multidimensional water system, that beneath the crust lies another sea, older and more secret, holding the memory of our planet's origins. Even beyond our world, water proves itself to be one of the universe's most abundant and enduring elements. Astronomers have detected immense clouds of water vapor surrounding distant quasars, brilliant beacons powered by supermassive black holes. One such cloud, discovered billions of light-years away, contains enough water to fill thousands of Earth's oceans, enveloping a quasar in a halo that glows faintly in infrared light. The existence of such a vast cosmic reservoir suggests that water was already widespread when the universe was still young, forming soon after the first stars and galaxies. It shows that the cosmos is not an empty, arid expanse but a fertile cradle where the essential ingredients of life are abundant. From interstellar clouds to icy comets and planetary atmospheres, water reveals itself again and again, in vapor, ice, and liquid forms. On Mars, frozen reserves hide beneath the dust. On Titan, rivers of liquid hydrocarbons flow through valleys. On Europa and Enceladus, immense subsurface oceans are kept warm by tidal forces. Across the galaxy, wherever hydrogen and oxygen coexist under suitable conditions, water emerges naturally, a universal solvent of creation. This realization reshapes humanity's search for life, no longer a lonely quest for anomalies, but an exploration of probabilities. If water is common, then life, too, may be common, a cosmic inevitability waiting for the right warmth and chemistry to awaken it. Water's molecular structure, simple yet unique, grants it powers unmatched by any other substance. Its polarity allows it to dissolve more materials than any other liquid, turning it into the universal medium for chemistry. It enables atoms and molecules to meet, bond, and react, creating the biochemical pathways that lead to life. Without water's ability to moderate temperature, transport nutrients, and buffer reactions, the delicate choreography of carbon-based chemistry could never unfold. Every cell, every breath, every heartbeat depends on it. Within a single droplet, countless molecular dramas play out: the birth and dissolution of compounds, the slow building of proteins and sugars, the very threads of DNA weaving together in the silent motion of liquid. In the vastness of the cosmos, this humble molecule holds the same importance as stars. Where there is water, there is potential, and where there is potential, there may someday be consciousness. Thus, from the crushing black of the ocean trench to the glowing clouds around distant quasars, water remains the architect of existence. It binds continents, shapes weather, sculpts stone, carries sound, and stores memory. It can crush metal or cradle microbes, burn with heat or freeze in eternal stillness. It is both destroyer and preserver, both boundary and bridge between the physical and the divine. The ocean's deepest pressure, the glacier's frozen patience, the steam that rises toward the stars, all are variations of the same eternal element. To understand water is to understand continuity, transformation, and endurance. It teaches that life is not defined by where it begins, but by how it adapts, that existence, like the